Hello, honors pre-calculus students. Mr. Cruzado here. The goal of problems number 1 and number 2 are to figure out what you notice and what do you wonder about. So if you look at this particular function, you could answer parts A, B, C, D, E, and find those limits. And hopefully you realize from our class discussion, for part A, the limit as you go off to infinity is the horizontal asymptote. So when you look at this particular problem, you should realize that the horizontal asymptote is y equal 3, which is the answer to part A. Then yesterday we looked at the left and right hand limits, which are the other parts on this paper. And I want you to observe the following. When this exponent is 1, around x equals -1, on one side the graph is up, and on the other side of the asymptote the graph is down. Likewise, for x minus 3, the exponent is 1, so for the vertical asymptote x equal 3, on one side of the graph it goes to infinity, and the other side of the asymptote it goes to -infinity. Now let's compare that to example number 2. In example number 2, if you look at part A and you find the limit as x goes to infinity, you get -2. And when you look at this graph, y equals -2 is the horizontal asymptote. If you were to multiply this out, you're going to get -2x cubed plus some other terms, divided by x cubed plus some other terms, and you should realize that that goes to -2. Now let's look at the asymptotes. For the x plus 4 squared, you get the asymptote x equals -4. Notice this exponent is 2. And on the graph, they're both going down. In contrast, for the vertical asymptote x equals 5, the multiplicity of that factor is 1. So on one side you are up, and the other side you are down. Problem number 3, the graph didn't come out very well, but we can talk about it. So for this particular problem, if you were to multiply this out, you get -5x squared over x cubed. When you send x to infinity, and you do get some other terms here, you get 0, so the horizontal asymptote is y equal 0. Now this graph didn't come out very well. This asymptote is x equals 3, and this other one is x equals 1. And the portion of the graph that is missing, because it's kind of off the graph, you know that there are no x-intercepts in this little yellow section. And I'm going to draw the rest of the graph here. I know that the graph is up here in that little blue section, and here's how I know that. The exponent is a 2 there around on the factor x minus 1. So that means around x equal 1, the graph is in the same direction, so they're both up. Then for the factor x minus 3, the exponent is 1, and notice on one side the graph is up, and the other side the graph is down. So the main idea for problems numbers 1 through 3 is what do you notice, what do you wonder, is if you have a function and you have some numerator, I'll just put some terms there, and then you have, say, x minus 1 squared, that too says as you go off, as you approach x equals 1, from both sides, they're either going to be positive, both positive infinity, or both negative infinity, meaning they're going in the same direction. In contrast, if you have g of x, you have some numerator, and let's suppose you have x plus 3, around the asymptote x equal -3, since the exponent is 1, on one side it's going to infinity, and the other side is going to -infinity. So that even an odd multiplicity, this 2 and this 1, tell you something about the graph. So that was the goal of problems 1, 2, and 3 of what do you notice, what do you wonder.